If you've ever worked near a back-end or data engineer, you've definitely seen this book, Designing Data-Intensive Applications. It's pretty much the Bible for anyone building big, resilient systems on the server side. But here's a thought. What if I told you that its real target audience isn't who you think it is? What if the absolute best book on back-end systems is secretly the most important book a front-end engineer could read right now? So it all starts with the book's 3 core principles for any solid system. And we're about to see how these so-called back-end pillars are, well, they're actually the very foundation of modern front-end development. Okay, so pillar number 1 is reliability. The book defines it basically like this. The system has to keep working correctly even when things go completely sideways. Hardware failures, software bugs, even as humans messing things up. Does that sound familiar? It absolutely should. This is the world you live in. When the network connection drops, what do? You build optimistic updates and retry logic. To handle those messy race conditions, you use request deduplication. To stop one bad component from crashing the entire app, you wrap it in an error boundary. This isn't some abstract back-end theory. This is everyday front-end reality. All right, next up, scalability. The main idea here is that as your system gets bigger, more data, more traffic, or just more complicated, you need to have good ways to handle that growth without the whole thing just grinding to a halt. And honestly, this just perfectly describes what front-end engineers are wrestling with every single day. Worried about your JavaScript bundle size? That's a scalability problem you solve with code splitting and tree shaking. Your global state is turning into a giant mess? You normalize it. You use memoization. Your app has to deal with a constant stream of real-time updates? Virtualization to the rescue. These are all front-end solutions to classic scalability problems. And finally, we've got maintainability. This one is so important. Over time, tons of different people are going to touch the code, and the goal is to make sure they can all get work done productively without, wanting to quit their job. And of course, we have a whole ecosystem built around this. We use linters and TypeScript to keep our code clean and safe. We design with component composition patterns. We write solid tests and document everything in Storybook. These are all maintainability patterns designed to make our complex UIs understandable and easy to change. Okay, so you can see how the high-level ideas match up, but the connection goes way, way deeper. The first really big revelation is this. Your application's state, it's a database. See, in the database world, there's this classic balancing act. Normalization versus denormalization. Do you store little pointers to your data using IDs to avoid copying it everywhere? Or do you just nest the data right where you need it to make it easier to grab? It's a fundamental choice you have to make. Now here's what's so cool about this slide. This is the exact same decision you're making when you structure your state in Redux, or Zustand, or even just plain old component state. Are you dealing with data that updates all the time or is shared in a bunch of places? You normalize it. Is the data mostly for reading and fits nicely into a tree shape? You nest it. You're already a database designer. You just probably weren't using that term for it. All right, if you thought that was a pretty neat connection, you better buckle up. We're about to pull back the curtain on the biggest reveal of them all. Those fundamental, super low-level patterns that power the world's biggest databases, yeah, they're already running inside your browser. Let's start with a simple one. One of the most basic ways to store data is something called an append-only log. It's exactly what it sounds like, a list of records you can only add to. Writes are super, super fast, but if you want to find the latest value of something, you have to scan backwards from the end. So where have we seen this before? The Redux Actions array is a perfect append-only log. Every single action you dispatch just gets added to the end. That's it. And that is the exact mechanism that makes the magic of time travel debugging in Redux DevTools possible. You're just replaying the log. Okay, but scanning a whole log to read something is pretty slow. So databases use indexes to speed things up. A hash index is just a simple map you keep in memory that tells you exactly where to find a piece of data. It makes looking things up insanely fast. We're talking O1 performance. And this pattern is literally everywhere on the front end. JavaScript's built-in map object, that is a hash index. And you know those key props you have to put on lists in React? You are building a hash index for React's reconciliation algorithm so it can find and update components without having to check the whole list. You are literally optimizing React with a database indexing strategy. Let's get a little more advanced. SS tables, or sorted string tables, are basically log files where all the key value pairs are kept sorted by the key. And this is a huge deal because it lets you do really efficient range queries, like get me all the records between key A and key Z. And where can we find this fancy data structure? IndexedDB. It's built on a real database engine called LevelDB, which uses SS tables under the hood. That's the secret sauce that lets you run powerful, efficient queries right there in the browser. It's a proper database, sitting right there on the client. And for one last little mindbender, you know how you do code splitting with React.lazy to break up your giant JavaScript bundle? Well, that's just segmentation, a core technique that storage engines use to manage their data files. Same idea, just a different context. So after saying all this, what's the big takeaway? It's simple, really, but it's also incredibly empowering. You aren't just a UI developer. You are a systems designer. The browser is not a simple little document viewer anymore. Modern web apps are dealing with the exact same challenges as any other distributed system. Unpredictable networks, having multiple versions of the app running out in the wild at the same time, and needing to be backward and forward compatible. Your app is a node in a very complex system. So this should really change how you think about your work. On your next project, start asking these systems-level questions. For reliability, ask, what happens when the API call fails? For scalability, how is this going to perform when this list has 1,000 items instead of 10? And for maintainability, is someone new to the team going to understand this code in 6 months? Because once you start thinking this way, it completely transforms how you approach everything, from how you design your state and handle APIs to how you optimize performance. You stop just building components and you start architecting resilient client-side systems. So the takeaway here is simple. The principles for building reliable, scalable, and maintainable applications are universal. They're not back-end principles anymore. Now that you know them, what system will you design next?